in evaluating the logistic regression model, the first thing you would do is to look at the beta values. The second thing you want to do is to look at the confusion matrix. Now, the confusion matrix basically tells us how confused the logistic regression model is, or conversely, how accurate the logistic regression model would be. Now, the confusion matrix essentially is a 2-row and 2-column table. The columns over here represent the actual values, while the rows represent the predicted values of the logistic regression model. And each of these cells have a specific meaning. So let's refer to the table. Now, each of these cells again has a specific meaning. So for example, true positive. What true positive means is that the actual value is actually yes or true or 1. And the logistic regression model correctly predicted it as such. True negative means that the actual value is false, no, or 0. And the logistic regression model predicted it as such. Now, false positive means that the logistic regression model predicted the value to be true or yes, but the actual value is false or 0. And finally, in false negative, the logistic regression model predicted false or no or 0, but the actual value is true, yes, or 1. So if we were to put all these 4 values together, we can determine the accuracy of the logistic regression model. So essentially, accuracy is the number of correct predictions represented by true positive plus true negative divided by the total number of predictions. That means true positive plus true negative plus false positive plus false negative. So that gives you an accuracy value. Accuracy ranges from 0, which is totally inaccurate, to 1, perfectly accurate. So these two edge cases are very unlikely in the real world. So chances are the values will be somewhere in between. So let's look at an example. We'll return to the student retention example. So let's say the university collects a bunch of data points, let's say 8 of them. Okay, so we know the IVs and we know the DVs. So we take these values, we give it out to our statistical analysis software, and then the logistic regression model is produced. So what the logistic regression model will also do is to try to predict the DV given the IV. So here we already know the actual DV values, and the logistic regression model is trying to make the predictions to see whether it is accurate or not. Okay, so shown in this table, in the first row, okay, given the student stays 4 years in the program, the GPA is 5, and the student is not working, the student actually stayed in the program. So that's the actual occurrence. And the logistic regression model predicted to be 1. In the second row, student stays in the program for 1 year, GPA is 1.4, student is working, the actual value is no, the student did not stay in the program, and then the logistic regression model predicted 0. So that's also correct. Now let's look at an incorrect prediction. So we look at the last row. The student actually stayed in the program, but the logistic regression model predicted no, the student did not stay in the program. So that's an incorrect prediction, and that's classified under false negative because the actual value was 1 and the model was predicted to be 0. So this slide here summarizes what we see in the previous table, essentially the predictions of the logistic regression model. So here we can see TP is equals to 2, which means that the model correctly predicted 2 students who stayed. Tn is equal to 3, that means the model correctly predicted 3 students who did not stay. Fp equals to 1 means that the model incorrectly predicted that the student stayed in the program, but actually the student did not stay in the program. And finally, Fn equals to 2 means that the model predicted there were 2 students who did not stay, but in actual fact, the student stayed within the program. So taking these 4 values, we can also summarize them in the confusion matrix. And from the confusion matrix, we are able to calculate the accuracy rate. So the accuracy rate would be 62.5%, which is derived from the number of correct predictions, which is number of true positives and true negatives divided by the total number of predictions. 5 over 8 gives you 62.5%.